All right, this is summer 8.2. That is chapter 2 of the 8th grade material, pre-algebra. We're dealing with transformations. Transformations is a really good section. It's oftentimes not covered very thoroughly. However, you will see it. It's very important for geometry. After you finish 8th grade Algebra 1, you tend to either take geometry over the summer or you'll take it your freshman year. And transformations are a big part of that. So hopefully you did enough practice in 7th grade, and this should be relatively easy, but we'll go over it. So triangles ABC and DEF are congruent. Typically, when you name them, A corresponds to D, B corresponds to E, and C corresponds to F. So their order is very important. If you aren't given that, and then you'll see angle sides and stuff like that. So which angle, so it doesn't really matter what the lengths are, and the shape isn't always necessarily the same, but we know that A corresponds with D, and they're in the same position, so they're making it relatively easy for you. B corresponds with E, and C corresponds with F. So they are positionally corresponding also. Which angle of DEF corresponds to angle C? C corresponds with F, as we saw. You can either use the figure, well, actually, you can't use the figure. This is the important thing. It tells you. Triangles ABC and DEF are congruent. What is the perimeter of DEF? The perimeter, well, if they're congruent, that means they have equal angles. This angle is congruent to this angle. They use those little signs, which are called congruency signs. This angle is congruent to this angle. And this angle, you have 3 tick marks, 1, 2, 3, is congruent to that. Now, also we can talk about the sides. The side lengths are also the same. That side length is congruent to that side length. This side length is congruent to that side length. And let's use black. 1, 2, 3 is congruent to this. And we again use those tick marks. So what is the perimeter? Well, the perimeter is going to be 5 plus 4 plus 6, which gives us a total of 15 centimeters. Tell whether the blue figure is a transition, a reflection, a rotation, or dilation of the red figure. Well, translation is a slide, meaning you're just sliding it over, especially on a graph. If we have a coordinate plane and we have this figure, and then we would slide it, it would be the same shape, and then it would just be slid over. That's called a translation. A reflection would be if I took this and I reflected it over the x-axis. So it would look like that. That would be a reflection. A rotation would mean that it would rotate some degree, and that would look like this, where it would be in the same location, it's just rotated. So that's rotation. This is translation. Blue is translation. Red is a reflection or a dilation. So this is an example of a dilation. Dilation gets bigger. So increases or decreases in size. So this is an increase in size. So this is considered a dilation. Tell whether the blue figure is a translation or reflection or rotation. This is a reflection over this axis. So that would be your axis, and the blue figure reflected over this line of symmetry. And so this would be considered a reflection. Tell whether the blue figure is a translation. It's a translation because it slid over to the right there. Yeah, that's good. I like that. Hold on. Tell where, oh, yeah, so this is going to be a rotation. So we rotated the blue figure, we rotated it 90 degrees. So we can take this point, actually, I'll show you another good way of doing this. You take this right side. So if we take this leg and then you take that, okay, how many degrees did it rotate? It rotated 90 degrees. So that was a 90-degree rotation. Sometimes they ask you for the degrees that you did it. Okay, so, and that's where these two intersect, and you'll notice that actually there's actually a point of rotation. So it would be something like this, where it rotates around a point, is actually the real way they do it. Whoa, I just want that piece. And I don't think I want that. There you go. We'll just erase that. That's good. The vertices of a triangle, those are the points, or the where two lines meet, are called vertices of a triangle. Are A, B, and C. Find the coordinates of the image after reflection on the y-axis. So we'll pull up a coordinate graph here, and we'll plot these points. Let's plot them. Let's get rid of my eraser. So we have the first point is going to be 2, 5, 1, 2, 1, 2, 3, 4, 5. The next point, and this is going to be point A. Next point is 1, 2. That's point B. And 3, 1. 1, 2, 3, 1 is going to be C. Okay, there is our figure. So we'll typically draw with a more of a line, but I did freehand. Find the coordinates of the image after reflection over the y-axis. This is my y-axis, so we're going to reflect it along this line. We'll draw this line so we can see it. We'll make it blue. We'll make it dotted, and so this is my y-axis. I'm going to reflect it over there. I'm going to erase this B value and make it a little bit closer to this. So if we reflect it over, that new point is going to be 1 away on the same y point. And it's going to be 1, 2, 3 away, 1, 2, 3 away. And then it's going to be up, and it's going to be 1, 2 away, 1, 2 away. And then if we connected the dots, let's connect it with a proper line. So it looks, well, that looks a little bit better. And the points, we would name them now. This would be A prime. This would be B prime, is closest to the axis, and C prime would be out there. Oh, good. Yeah, so they have A prime, B prime, C prime. So the coordinate of A is going to be -2, 5. The coordinate of B prime is going to be -1, 2. And the coordinate of C prime is going to be -3, 1. And notice, we notice this pattern. When you reflect it, it just takes the negative value of each of your x's. Your y value stays the same. So when we do x comma y, this is the mathematical notation. It produces -x comma y. This would be reflecting over the y-axis. This is a formula that you can apply, and you'll deal with that in geometry quite a bit. The vertices of triangles, same one. Find the coordinates of the image after a rotation of 90 degrees clockwise around the origin. So notice we have clockwise. That's a direction. So we're going to be rotating it 90 degrees this way. That would be clockwise. The counter to that would be counterclockwise, as you could hear it. All right, let's draw those points again. We have our points. We have 2, 5, 1, 2, 1, 2, 3, 4, 5. We have 1, 2, 1, 2. So this is A, this is B, and C was 3, 1, 1, 2, 3. Did I do it wrong? Are those the same or did I do it wrong? Hold on. No, I don't want that. I don't remember it being. Let's see if I drew it incorrectly. I think I did. I did. Sorry. Well, these are correct. I just didn't draw it correctly. 3, 1 would be down here. Duh. Sorry about that. So let's get rid of that. Let's move this down to 3, 1. Let's move C down because C is going to move too. That's going to move. Sorry about that. That's kind of going to move. Let's grab C, please. C prime will be 1, 2, 3, 1, negative 3, 1. Yeah. So that actually goes to here. Sorry. But I caught it, isn't it? So here's another example. So we talk about this quite a bit about catching our mistakes. So making mistakes is natural. It's gonna happen. It's a realistic thing. It's can you catch them? Are you aware? So even though I moved on to the next problem, I still was thinking about the problem before because I remembered some of the aspects of it. So when I was about to do this, I remembered the object that I drew was an isosceles triangle, that C was on the same plane. But when I went to go draw C here, I noticed that that was not going to happen. I was going to put it here, but it's actually here. So that was the memory. In my head, I remembered that. So just because I'm moving on to the next problem doesn't mean that I'm not thinking about the problems that I've completed. It's kind of important, and Mr. Mac doesn't have a great memory. So the fact that I remembered that was pretty good. Okay, now we're going to rotate it. So here's an interesting way to do this. We can take, let's make it blue. Let's make it dotted. And if we drew a line out, that's why I said it rotates around a point. And if I made this 90 degrees, where would that point go to? That point would actually go to here. If we drew it out, we notice that that would be a 90-degree angle. That point rotated 90 degrees clockwise. So this is going to be my new B point. That's my B prime. And if we rotate the A, if we drew it out and rotated it and made it 90 degrees, that point, A, would be here. It would be 5, 1, 2, 3, 4, 5, 1, 2. It would be up here. And if we rotated C, that would be 1, 1, 2, 3. So this is A prime, this is C prime. And if I connect the dots, let's make sure it's... Does that look like my figure rotated 90 degrees? Sure does. Absolutely. And now let's look at the points. A prime is going to be 5. Whoops, sorry. A prime is going to be 5, comma 2. We can do it in blue. B prime is going to be 2, comma 1. And C prime is going to be 1, comma 3. So what do we notice? We notice that all points, when we rotate 90 degrees, when we rotate 90 degrees around the origin, what happens? Well, we actually reverse our points, our coordinates. Our X now goes into the Y position. Our Y value goes into the X position. And that's kind of cool. And that will happen for every figure rotated 90 degrees clockwise. The vertices of a triangle are 2, 5, 1, 2, 3. Find the coordinate. Let's increase that view a little bit. 150, 200. Let's do 200. Find the coordinates of the image after a reflection in the x-axis and then a rotation 90 degrees counterclockwise. Counterclockwise this time. So that's important for us to pay attention to. So we know what happens when we reflect over the x-axis. Well, let's see if you can think about how that might affect our object. So we have 2, 5, 1, 2, 1, 2, 3, 4, 5. And then we have 1, 2, and then we have 3, 1. And let's draw that figure. Looks a whole lot better that way, doesn't it? That's A prime. This is B prime. Oop, not prime, sorry. That's just A. That's A. This is B. This is C. Did I do that with the other one? I did do it. A prime. Oh, no. Good. Yeah, that's good. Okay. First thing, we're going to reflect over the x-axis. So when we reflect it over the x-axis, we're going to keep our x value, and our y value now gets flipped from positive to negative, or the opposite of what it is. So this is going to be 2, negative 5, 3, 4, 5, and this is going to be 1, or this is going to be 3, negative 1. So that's my first translation on it. So now I've done that. So let's highlight that in blue. So when we reflect it over the x-axis, and the mathematical thing for is going to be x comma y. This time your x value stays the same, and you're going to do the opposite of your y value. That is a reflection over x-axis. So those points now become 2, negative 5, 1, negative 2, and 3, negative 1. Why did I write it? This is not the answer because notice double prime. So this is going to be A prime. I like that they notated it double prime, telling me that I'm doing two types of translations to it. So the first one gives me this. Now, mathematically, I could have just applied these rules back to back. So what is the rule going to be for counterclockwise? So now we're going to rotate it backwards over the origin, and we're going to change our values. But what does that change? Which one does it change? Well, it's going to change it to go back to, so what do we need to do? Well, it's actually going to be, here, let's do rotation. No, because we're going to do it in red. I want my red rotation, or my, rotation. Rotation, 90 degrees, counterclockwise. Counterclockwise. So this point is going to go up here. So this point is currently, that is my B point, that is 1, negative 2. So that is actually going to be 2, 1. So 2, 1, 2, 1 takes me there. And does that look like a 90 degree? Yeah, if I drew out my dotted line again from the origin, remember how I did that? If you draw that point and that point, does it look like a 90 degree? Yes, it does. Absolutely does. So we rotated that 90. Let's do our other point. So our next point, that would be B double prime. That is my B value. My C value, let's move that over a little bit because, sorry. Ugh. Let's move that over because that's my middle value. That's my B value is here. My C value is going to be 1, 3. 1, 3 is here. That's kind of crazy. That's C double prime. And then my A value is going to be 5, 2. 1, 2, 3, 4, 5, 2. And let's connect them and see if that draws, if that draws my figure. Does my figure hold true to that rotation? And that's going to be A double prime. So if we took this value, or this figure, and rotated it 90 degrees, did it hold position? Sure did. Yes, it did. So the answers are going to be 5, 2. This is going to be 2, 1. And this is going to be 1, 3. And let's talk about that rotation. What was the mathematical aspect of this rotation? The mathematical, let's do this. Let's move you guys down a little bit. The mathematical is you take your xy value, and what did we do? Well, first of all, we flipped it, correct? And it became the opposite of y comma x. So that would be the formula that you can apply. So if we took any point on here, if we took another one, we would take these values, we would apply this to it and create a new value, and then we would take that new value and apply this to it. So that's what we're doing when we apply those other mathematical formulas, the translation formula. The vertices of a triangle, find the coordinates of the image after a dilation, with respect to the origin using a scale factor. So whenever we do dilations, we have what we call a scale factor. And then a translation, that's a slide, of 2 units to the left, 1 unit up. That's important. Okay, so a scale factor. We can do it without. Let's do this one without a diagram. So a scale factor is we're going to take each value and multiply it by 2. So if we have A is 2 comma 5, so we're going to become A prime turns into 410. I didn't even check to see if all those were correct. Let's look at 9. Where is 9? 9, 5, 2, 2, 1, 1, 3. Yup. 5, 8. 5, negative 2. Did I make a mistake? Oh, yes, I did. Hello. Sorry, it's rotation. Oh, yeah, sorry. After rotation, yeah, that's negative. Sorry. We didn't even talk about the, oh, yes, we did. Rotate is not, sorry, that should be the opposite of my, not my x value, my y value. So this should be negative yx. Negative yx, did I do that correctly? So again, going back, I kind of felt like I maybe missed something. No, I didn't. I went and looked at the answer. That's not true at all, Mr. Mac. 2, 5. So that is, B becomes 2, 1, 2, negative 1. Hello, 2, negative 1. Duh. So this is actually going to be opposite of x. So it's y negative x. I knew it couldn't be the same as rotating 90 up, because rotating 90 up is negative y positive x. So this can't be negative y positive x. Can't be the same, or else it would be rotating. So that would be negative 2. That would be negative 1. That's correct. And this is going to be negative 3. Sorry. 1, negative 3. 2, negative 1. 5, negative 2. My bad. Sorry. A little bit of a mistake there. But I had the right formula. I just didn't apply it correctly. Those are correct. That's correct. That is correct. Those were done correctly. And 10. So let's talk about that. Okay. So a scale factor, that's good, times 2 times 2. And now a translation. So this, let's do this. So for every x comma y, my A prime is going to be 2x comma 2y. Okay. And then that's going to be a scale factor. Scale factor of 2. And then if we want to translate left 2 and up 1. Well, for every point, you're going to go left 2, so that's x minus 2. Left is negative, and up 1 would be y plus 1. So we multiply it by 2. Now here's our new point, and we are going to turn that into, let's move this stuff down a little bit so we can write our answers later. So we're going to subtract 2. So A double prime is going to be 4 minus 2, which is 2. and 10 plus 1, which is 11. So A double prime is going to be 2 comma 11. And then we can do the next value. We can take our B value. So our B value, no, that shouldn't be prime. That should just be B. A, I mean. So our B value is 1 comma 2. If we do B prime, we're going to multiply everything by 2. So that's 2 comma 4. And then B double prime is going to be minus 2, which is 0, and add 1, which is 5. So my next point is going to be 0, 5. And then my C value is 3, 1. And we're going to multiply it by 2. So C prime is going to be 6 comma 2. And then C double prime is going to be minus 2, which is 4, plus 1 is 4, 3. So my C double prime is going to be 4 comma 3. So you can also do it without a graph. So that's the benefits of having these formulas, these ways of knowing what the translations are going to be. Kind of cool, kind of interesting. Draw rectangles with the given vertices in a coordinate plane. Okay, let's do negative 4, 4. So negative 4, 4. Negative 4, 4 takes us here. Let's see what that value, that is, that's just a point, 0, 4. So 0, 4. And then we have 0, 2, 0, 2, 0 on the x, 2 on the y, and then negative 4, 2. So here's my rectangle drawn correctly, and that's it. That's all we needed to do. That was kind of nice and easy. Okay. All right, let's see what the next question is. That was kind of good. Rectangle, negative 2, 2. So negative 2, 2 is right here. Let's draw 0, 2, 0, 2. Let's do 0, 1. And let's do negative 2, 1. Okay, that was equally as easy at this point. And that's what our rectangle looks like for the next rectangle. That's rectangle B, I think. Okay, now, rectangle C. Okay, negative 6, 6. So negative 6, 6 is way up here. Oh, you're off of my graph. So 4, 5, 6. Oh, that's going to be right there. So negative 6, 6, 0, 6 is right here. 0, 3. And I would assume that it's negative 6, 3. Negative 6, 3. Let's connect the dots. Okay, now what's the question? What's the question? Which figures are similar? They're all similar. They're all similar because they are proportional. Different word, similar. Okay, similar means that they are proportional. Proportional. How do you spell proportion? Proportion, T-I-O-N. Proportional. If they say congruent, they have to be the same exact lengths. Okay, proportional is there's a scale factor to them. All right, so these are all similar, all of them, because they are the same shape. They are the same distance away from each of them. They increase on the same part. So that's important for you to know that. Okay, so the lengths are proportional. Number 12. Let's look at number 12. Translate point XY 3 units left, 5 units up. Then translate the image 5 units right and 2 units up. What are the coordinates of the point after the translation? Okay, so we can do it two ways. We can do it this way, XY. So our first translation, we're going to go 3 units left. That's left is negative. 5 units up is this. And then we want to take our new value and translate it 5 units right. That's positive, and 2 units up. Now we can add these together and we can go directly to our translation. We don't have to do these 2 steps. We can add them together, so it's actually end translation is plus up to, or to the right 2 and up 7. So that's way more efficient. Okay, so after, what are the coordinates of the after? Is going to be plus 2, y plus 7. Yeah, x plus 2, y plus 7. So that actually answers it. They didn't give us a specific point, but this will be our end translation. So this is our answer, x plus 2, y plus 7. It's a good one. I like that. The 2 figures are similar. Okay, that means they're proportional. So if this side corresponds with this side, and this side corresponds with this side, we know that we can write a fraction. We can say x over 14 is equal to 10 over 8 because we have corresponding parts, corresponding pieces. We have the same trapezoid, the same side, the same side. And now we can either multiply or we can cross product. So we would have 8 times x equals 10 times 14. 8x equals 140. Divide by 8. Divide by 8. X equals 16. What's 60? 60. 7. 60. What's that? 2. 7.25? 17.25? Is that what it is? 140 divided by 8. 17.5. Yeah. 17.5. So the length of x is going to be 17.5. Find the values of the ratio, red to blue, of the perimeters of the areas. Ooh. Write the ratio. I'm assuming that these are regular. What? Oh. Ratios of the perimeter. Okay. So the ratios of the perimeter. That's very interesting. So what am I multiplying by? I'm multiplying ratio. Yes, so the perimeter is going to be 1-dimensional. The area is going to be 2-dimensional. Okay, so I got it. So what are we multiplying? 8 times what equals 14? Well, you'd solve for x, and you get 14/8, or x is equal to 7/4. So the ratio of the perimeter is going to be 7/4, and because it's 2 dimensions for the area, meaning the length and the width, that's going to be 49/16. That's a very tricky one. We just square because it's that proportion by the length and the width, or the height. So since area is 2 dimensions, we would take this 1-dimension figure and square it. We multiply it by itself. So that's 1 dimension. And then that's a good one. That's a very important. And what would volume be? Volume would be how many dimensions? 3. Yeah, 3 dimensions. So we would do 7 to the 3rd and 4 to the 3rd. So 7 to the 3rd is like 219? What is that? What's 7 to the 3rd? 3, not even close. 343 over 64 would be the proportional value. 14. A widescreen television measures 36 inches by 54 inches. A movie theater screen measures 42 feet. Notice feet by 63 feet. Are the screens similar? So do we want to convert it to the same units. Let's check it out. I kind of want to. My knee-jerk reaction says, hey, let's create a proportion, not inches, because inches and feet. So I'm going to lean to the fact, so 36 inches is going to be 3 feet, and 54 inches is going to be, what's 54 divided by 12? 4.5. Okay. Whoop, not music, 4.5. Sorry, we don't need music, Mr. Mac. 4.5. 4.5 feet equals 42 feet by 63 feet. So are they similar, meaning are they proportional? So we can multiply these, cross multiply, or see what times 3 equals 42. Let's do 42 divided by 3 gives us 14. So if I multiply 4.5 times 14, the proportion, times 4.5, do I get 63? I do get 63. That is awesome. So yes, it is proportional. I like that a lot. So we multiplied it by 14 and this by 14, and we got the same values. So they are proportional, would be they are proportional. If we, yeah, see, we'll just leave it at that. I like that a lot. You want to use a rectangular piece of fabric shown to make a pair of curtains for your window. Name the types of congruent shapes you can make with one straight cut. Explain how you could draw an example of each type. Curtains. Well, I could draw it. Name the congruent shapes you can make for one straight cut. It depends. You want to use rectangular piece to make a pair of curtains for your window. Well, are my curtains going to be rectangular? So I could do it and we can do it in a couple ways. We could do it in this manner. Well, let's pick a different color. So one of the ways is I can cut it right down the center, right? That would definitely create a curtain. It would create 2 curtains, a pair of curtains, by dividing it that way. So I could do it, my axis of symmetry, that's an axis of symmetry. So that would be a horizontal axis. We could do it another way. We could do it this way. Let's pick a different color. Let's use those. You could cut it this way. You could cut it vertically, and you could have 2 equal congruent shapes. And that would be a vertical axis. And then here's the question, right? This is the interesting, weird question. Well, technically, could we cut it along its diagonals? So yeah, they would be congruent. They would be weird curtains because it doesn't say name the types of congruent shapes. Oh yeah, so we can do, yeah, so we can have a diagonal, and then horizontal would be rectangles. So those would be rectangles. This would be a rectangle also. I just noticed the word shape, congruent shapes. So a diagonal axis of symmetry. And there would be 2, would be triangles. And then the other axis of symmetry would be along the other diagonal. Let's do that in, not green because we're in green. We already used purple. Let's use this one. So the other diagonal would also be a triangle. So both diagonal axes. axes, and those would be triangles. So technically, you have 4 different axes of symmetry. Okay, I like. Yeah, I don't think they have the answer for that last one. So we've gone over the answers. Yeah, they don't have an answer here, unfortunately, which is kind of lame. Give me some answers. All right, good luck. 8.2 is done.